Hi everyone and welcome to Nordic Serverless, this time on the topic Alexa, who's ringing my doorbell. My name is Gunnar Grosch and today I have my friend Goran Vuksic with me. Goran is a technical manager at Stratiteq. So welcome, Goran.
Thank you, it's nice to be here.
All right, so tell everyone what we are going to do today.
So we were thinking a bit like to make some fun project with Alexa, and it's kind of not often to do hardware projects. We had the online meetups, but that's what we are trying to do today. So we will make one Alexa skill using the IoT. We will use the camera and take a picture, and then Alexa will try to recognize who is in that picture.
Yeah, and we'll be doing it in two parts. So I'll take care of the IoT part, getting the IoT device up and running and setting up the serverless backend for that. And then over to you, Goran, for the Alexa skill part.
Yeah, I will build the Alexa skill. First, I will show the easiest way to make a skill, and then we will make the skill from scratch.
That's great. So, but to kick things off, we want to just give a short background on Alexa, Echo devices, and Alexa skills. So I'm going to leave it over to you, Goran, to show a bit of that.
Sure. I prepared just a few slides to quickly explain what Alexa is. And when we talk about Alexa, we usually think about this device. Just you made short introduction, like few words about me. I work in IT 15 years, and now I work as technical manager for Stratiteq here in Malmö, Sweden. And I find Alexa really interesting, and I enjoy this natural language processing, and I like how Alexa is now everywhere. I got my Alexa skill builder specialty. So if you want to learn more on Alexa topic, like, it is highly recommended. So quick about Alexa or Amazon Echo device. It's a smart speaker. You can talk to it, ask about the weather, the traffic, and so on, but you can actually do much more. And this Echo version, Echo comes in many versions, like you can see 3 devices now here on the screen. On the far right, it's the first generations with 2 buttons on top. Second generations added 2 more buttons for volume up and down. They come in many different sizes, and also comes as a device with the display. So here we have Echo Show and Spot. Those displays are pretty basic, just display the basic information to the user. Under the hood, Alexa is mostly a speaker that records the voice and sends it off to the internet for recognition in the cloud, and gives you back some answer, like tries to understand what you are asking it. There is like around Echo lot of devices in this ecosystem, and we have Echo buttons, which is a gadget mostly used to play the games. For example, play the game Who Will answer the question the first. There is Echo Connect, which enables you to connect to the phone line, so Alexa can make calls. There is Echo Sub, like if you want to listen some music with the deep bass. And there is Echo Wall Clock, which looks like a standard clock, but for example, if you set reminder on Alexa, it will show you how much time there is left. Some newer things, Echo Frames. This is not augmented reality frame. It is a frame, standard frames, nicely designed, that has Alexa inside of it, and Echo Loop ring. So basically, idea is to have Alexa anywhere near you, so you can just, while you install talk to your glasses or talk into the ring, like Alexa sent reminder that I should buy something, or perform any other action you want with Alexa. I don't know, have you tried it? Setup is super simple. You just plug it in, connect to the internet, and you can start using it. And beautiful thing about Echo is that it nicely fits into this Internet of Things. And over here we have one example where user is turning on kitchen light with Alexa, so giving it command, Alexa tries to figure out what needs to be done and turns on that light. Actually, this is setup I have at home. When I get home from work, I take food and sit in front of TV, start eating. Then I figure out, oh, I forgot the light in the kitchen. Then it's much easier to say, Alexa, turn off the light, than to stand up and go there. I know both things are not healthy, but that's some small thing I do. And since we started with IoT, I would ask you, Gunnar, to continue with to show what we prepared today.
All right, great. Thanks, Goran. So I'll take it from here for now. And I'm going to show a bit about what we plan on doing more in detail. But first, there we go. Just short about me. My name is Gunnar Grosch, as I said, and I'm an evangelist and a co-founder at Opsio, based in Sweden. My background is in IT in very different areas, or in most areas, with development, operations, and in management. I do a lot of this community work, organize communities, and help run both AWS and serverless meetups in the Nordics. I help organize both Serverless Days conferences and AWS Community Day conferences. I've been named an AWS Serverless Hero recently, and am extremely proud over that. And I have 3 kids who really love to use my Echo devices at home. I'm not sure how many we have today, but 14, 15 devices, I think, and they use them constantly all the time, even though it's mainly English at the moment still. So today we're going to use an IoT device that's called the Esp32 Cam. It's a really small device, as you can see. It's a cheap device as well, but it's based on the ESP32, but with a built-in camera. And you can get these devices for below $10 US. So they're really simple and really simple to get, really cheap and really simple to get started with as well. One thing to remember with these, since they are so small, they don't have a port for connectivity like micro USB. So you have to have that externally and connect it through the pins. Just something to remember if you're ordering one of these devices. The ESP32 is something that AWS IoT hero Nathan Glover wrote a blog post about just a few days after me and Goran decided upon doing this. So he has a great blog post that explains how to get started using the device. We're still going to look a bit about that tonight as well, but do look at his blog post for more details on how to get started using the device. Mainly what we're going to do is hook the ESP32 Cam device up to the service in AWS that's called AWS IoT Core. And then we're going to use serverless functions with AWS Lambda to, in this case, process an image. And that image will then be stored in the object store, AWS S3. So the entire backend is serverless. We only pay for the requests that we use, which in this case is going to be really small. And when we have the device hooked up, it will use these services in the backend as soon as we call them. So it's a simple setup, but really effective for this specific use case. More in detail, what we'll do is, first off, we're going to have a Lambda function that posts or publish a message to an IoT topic. That IoT topic in turn is then read by the IoT device, the ESP32. So when a new topic is posted or a new message is posted to the topic, the IoT device will get that message, and when it gets it, it will take a picture and in turn post that to a different IoT topic. So this will be on demand, which means that when we run our Lambda function, the IoT device will take the picture. So I find that to be quite a good use case for these kinds of devices. When the message is published to the second IoT topic, a Lambda function is invoked, and it takes that message, which contains the actual image, and processes that and stores it in the S3 bucket. So this is the entire flow of this application. So each time the first Lambda function is invoked, it will take a picture and then ultimately store it in AWS S3. So that's what we're going to look at now. So moving over, I've created a repository in GitHub with all the bits and pieces for this. It contains mainly two parts. It's the one folder that contains the logic for the device, and another one for the backend services. So we'll start by looking at the device part. So we're using the service AWS IoT and IoT Core. What you want to start off by doing is registering your device or thing, as it's called in AWS. And there are easy ways to do this. You just create a device following the wizard that's visible in the console. You can, of course, do it using the CLI. And going back to Nathan Glover's blog post, he has the steps for doing it using the CLI there as well. But just to get started in an easy way, you can use the wizard in the console. And what happens when you're creating devices? First off, you of course get the actual device. You're naming that device, but then you're also creating the things that are needed for it to be able to communicate with IoT Core. So you're creating what's called a certificate, and that certificate is what is doing the authentication, making sure that your IoT device is allowed to do things in AWS. So it creates the certificate, and based on that certificate, you'll get, well, first the public part, but then also the private part, which is what you need to store on your device. We'll look at the code for that just in a few moments. You'll also create a policy, and the policy works more or less in the same way as any AWS IAM policies. So it's a statement that says what can this, everything that's connected to this policy, what can it do? And in this case, the device is allowed to connect to IoT Core. It is allowed to subscribe to the topic, the subscription topic that we'll create. It's allowed to receive messages on the topic, and it's also allowed to publish to a different topic. So that's a simple policy document that we need to create as well. So let's move over to VS Code and look at the code behind this. So this is the backend folder. I prefer using VS Code when working with IoT devices, like these simple devices, because there is an extension for Platform IO, and Platform IO makes it easy to flash your devices with whatever you are developing. and gives you quite an easy way to manage the device, but also have control using VS Code. So let's start off with the device. If you're using my repository, in the device folder, you'll have a template for the policy document. So just use this, you can update it. You need to have your region, of course, and your account ID. Then you update it with the name of the client, the name of the topics that we'll be using for this IoT device. There's also a configuration document, which has a template. And then I have also created a document here based on that template. I'll give you a look at that shortly. In this configuration document, you need to define everything that's needed for connectivity. So your Wi-Fi SSID, your Wi-Fi password, your device name, which of course should match the one you've created already in IoT Core. Here you also define the topic as we saw in the policy document. So they need to match, of course, as well. And then you need to add your IoT endpoint. And the endpoint is the endpoint for your device gateway, which is the fully managed service where your IoT devices connect to either listen to messages, publish messages, update configuration, and so on. So this is your specific endpoint. You can get that through the console or using the CLI, using a describe endpoint command. Then you need to add the certificates that you created earlier. So if you did it through the wizard in the console, you have been able to download all the certificates. So there's first off the Amazon Roots CA. So that's the generic one. So just open that file and paste the contents. And then you have your device certificate. And lastly, you have your private key. Closing this and instead looking at my template, it looks like this. So I've added the SSID and password, the device name. My topics are named Serverless IoT Cam, and I have the subscription one and the publish one. This is my endpoint, and these are my certificates. So you can see how it's supposed to look. And then when we've done these changes, quite simple changes, we are actually ready to flash this device with the code. But I'm also going to show you how the main application looks as well that will be flashing to the device. And so there is a lot of code for the configuration and initialization of the camera and the camera module. But that's more or less boilerplate configuration, so nothing to look at there. But we've defined the camera model and the camera module as well. But then we do the connection to Wi-Fi. We're getting data from the client or from the camera. So since this is something that has been provided from makers of this chip and this module, we have this as functions ready to use. But we're getting the camera image. We have a callback function for receiving the message. So it's listening to the subscribed message. Let's just scroll down a bit. Here, we're looking at the connectivity part of it. We're doing a connection to MQTT. That's the messaging part of IoT Core. Connecting using our device name. And we're subscribing to our subscription topic, the one we configured in conf-h. If we're able to connect and able to subscribe, everything goes just fine. We have the setup part where I said that there's a lot of setup for the actual camera, but nothing really to touch there unless we want to make changes to output, the image size, for instance, or the JPEG quality. We can do those changes here. But one thing to remember is that since we're using the message in the topic, and the one that we're publishing, we are limited to the size of the maximum size of those messages. So the images can't be too large for it to fit in the message size. When we have all of that set up, here we go. This is the part where we're doing the actual connection to IoT Core. So here we're using the certificates that we configured earlier. We're using the endpoint that we set earlier. And this is the connect function that we saw a bit further up. And then when those are set, when we have the connection in place, our device will just loop and wait for incoming messages on the subscribed topic. And when it gets a message on the topic, it will perform what we told it to do. And in this case, when it, let's go up. When it gets a message in the callback, it's supposed to do this part. It uses the publish function in the MQTT client and publishes to the publish topic using the image that it has created using the camera functionality. And if all goes well, we should receive a message that says that it has been successfully posted. So that's more or less everything that we need for the device to get up and running. So change the configuration or create the configuration file and then publish it using Platform.io or flash it. So let's just try this out to see how it looks. In the console, we have this part for test where we have a web-based MQTT client, so we're able to test our devices. So we can subscribe to our two topics, Serverless IoT Cam Sub, and the other one was Poop. There we have those. And the names here can be a bit confusing, but subscription is for the device, the one that the device subscribes to, and the other one is the one that the device publishes to. So for the device to get a message, we should publish something to this Serverless IoT Cam /sub. And we can do that as well in the console. So since I didn't do anything with the actual message in the device right now, we can more or less publish anything to it. But this could be some part of the logic as well, of course. Depending on what the message is, we could do different things. So we're not limited to only taking pictures with this device. It could have different logics based on the message. But in this case, we'll only post a message to see what happens. So publish the topic. There we go. And as soon as we did that, we can see that a green dot shows that something got published to the other topic, which in turn should mean that our device actually did something when it received the message. So going there, we can see that it has actually published something, and in this case, it's raw hexadecimal, so we can't really know exactly what that is, but I'm guessing it's an image. So every time the device receives something, a message on its topic, it will post more or less a reply on the other topic, which is exactly what we're after. So let's look then at the other part of this. The other part is the backend. So this is now based on the serverless framework for easy deployment, and built more or less in the same way. So there is a template to base your settings on. So you can just copy that template and create a file that's called env.yml. And the template contains a few different parts. And the ones we actually need to update are these ones, and they should match what we had before. So we have the IoT endpoint, which should be the same endpoint that we're using for our device in the conf.h file. And we have a publish topic, and we have a subscribe topic. And just remember here that it should be the opposite from before. So this is the topic that Lambda will publish something to. So that's going to be the subscribe topic for our device. And the other way around, that the subscribe topic for Lambda is going to be the publish topic for our Lambdas. All right. So just create your own file based on that. For me, this is the endpoint. This was the name of the topics. The other settings are if we want to save this to a specific path, or if we want to give it a specific name. We'll look at how that works. We can also decide upon what the payload that we're going to send to the device is going to be. And like I mentioned, right now it doesn't matter, but here we could create some logic for say telling the device what it's supposed to do, rather than just doing something, the only thing that it does right now. Let's open the serverless YAML file. So this consists of two functions. First, let's look at the second one, the one that's called publish handler. No, let's look at the object handler. No, the publish handler. All right. So the publish handler is the one that is publishing a message to a topic, and to the topic that the device is listening on. So it's fairly simple. I've added it right now with an API gateway in front. So we're able to post to API gateway, which invokes Lambda, which in turn then creates a message in the topic. The other one is the object handler, and the object handler is the one that is subscribing to the topic that the device is posting its image to. So as you can see, it instead has an IoT event, and there it has this query. So it should select data from, and this is a variable that is our IoT topic sub from the environment YML file we had before. So looking at the code, the publish one, fairly simple. It uses the AWS SDK and IoT data to publish a message to, let's see, there we go, IoT data publish. And based on the settings we set before, it publishes to a specific topic. It uses a payload that we set, and it chooses the quality of service. We have two settings here. We can have it as right now, it's quality of service 1, which means that the message will be delivered 1 or more times, or quality of service 0, which means that it will be delivered 0 or more times. But 1 is the default in this application. The other one is the one that takes the message from the subscription. And in this case, it also uses the AWS SDK. But then in the object body, since this is invoked when there is a message in the subscription topic, in the object, in the event, the data that is sent in the event is the actual image data, base 64 encoded. So we're just turning that into a variable, which we later on then are storing into S3 as the body of the parameters for our S3 put object. And we have a few settings here. One is that if we in our environment file have defined an object name, it will store it with the same name each time. So basically overwriting the same file. If we're not entering an object name like we have right now, it will instead just save it using a timestamp. So the standard JavaScript timestamp. So that's the setup for this application, the backend. So let's try it out and see if it works. So this is Postman. Let's just get the endpoint first. So this is our publish Lambda. A bit slow. Very slow. All right. So we go. This is our API endpoint. So let's put that into Postman and post. I want to post something. Go. Right. So we posted this to the API gateway, which then in turn invokes that publish Lambda. And here we can see what it was actually sent to the IoT data publish. So this is the topic that we're using. This was the payload that I entered and the quality of service 1. So when we did that, if all goes well, we should have, well, right now a weird picture of my desk. So let's move over to S3 and see if it worked. That's the latest one. Yeah, that's an image of my desk with lots of cables. So let's just try it once more. And this time, how about a selfie? So as soon as I post, here we go. Moving over to S3. New picture. Hey, there we go. So it works. And it's really quick. And since the IoT device it's just looping and waiting for messages. So as soon as the message is in the topic, it will take a picture and it will publish that. And the Lambda invokes directly as well and stores that in S3. So we're talking milliseconds from publishing a message to actually having it in S3. So that was it for my part. And with that, Goran, was that fine?
Yes, but one thing we will use, since AWS recognition is not aware of you yet, you need to be a bit more famous. Do you have a picture of some famous person so we could use that?
I have this book, George W. Bush. He's semi-famous, right?
Yeah.
So let me try to... All right. I'm using Postman once again. There we go. And let's see if we got a new picture of George W. Bush. There he is.
Awesome.
All right. So let me stop my screen share. Okay. So over to you then, Goran, and take it from there.
Thank you, and thank you for a nice demo. So we build the first part, right? From our IoT device, we are taking the picture and uploading it to the cloud. We got it in our S3 bucket over there. And you could set it up in many different ways. I think you could set it up on door to take a picture automatically every now and then, or you could set it like when doorbell is pressed, that picture is taken there. But that's up to you if you go for implementation. Like we are back in our IoT world, and now we are going to code a bit. We are actually going to build Alexa skill, and now I switched into the Alexa developer console. It's on developer.amazon.com/alexa/console/ask. That's where I am at the moment. And over here, I have some list of skills. I will create a new skill. And I will show you now how easy and quick it is to make a skill. So first of all, we'll make some skill Nordic. Let's call it Nordic skill, and we want to build this Alexa hosted Node.js skill. That's what's currently selected. So we will click create skill, and now we are asked what kind of template we would like to use for our skill, and we will say hello world skill. There are some other templates you can start with to try it out, like playing a high-low game, for example. But now we are using basic hello world skill, and we click choose. And what happens now is that our Alexa developer console will prepare our environment, so everything will be put in a place. This voice model will be prepared, and our environment, which already consists of some Lambda functions, will also be ready. It will probably take about a minute. So in this skill, what we are going to do, we will define one intent. Intent means an action that we want to do, and we will try to trigger that intent via the Alexa simulator, which we will find in our console. The thing is, when you have Alexa, immediately as you set it up and connect it to your account, this skill you are building here in a browser, you can invoke it directly via the Alexa. This is how Alexa developer console looks like when you enter it, right? On the right side, bottom right, you can see some messages popped up, like, are you new over here and that build was successful? I will close it up so we can take a closer look at the console. On the right side, we have skill builder checklist. And since we picked the skill that is built from template, this checklist is already complete. So we already have invocation name, define some intent, model is built, and endpoint is ready. Basically, everything's ready to start using. When I introduce it to this environment, I will go back and I will build skill from scratch. So I will go all the way what needs to be done for each of those check marks to be set. On the left side on our menu, we can see some options over here, and one of them is invocation. We call this Nordic skill. I will just note it down so I don't forget it in a second, as it usually happens. Those two words are invocation of our skill. So if we want to start it up, we would say, Alexa, open Nordic skill, right? And that skill has some intents. It has hello world intent and has some built-in intents. Intent is an action that can happen. So with this built-in intent, we can ask for help, we can cancel some flow, stop, and navigate to home. And we have one intent that is built on, and that is called hello world intent. Let's click on it. Let's take a look what it is. So this intent will be started with the different utterances. Those are hello, how are you, say hi world, say hi, hi, and so on. So there is a total seven of them. When hello world intent is triggered, it will execute some part of code and give some result back. So let's define one custom intent. So let's say that we want to add intent which is called door intent, because we'll be checking who's at the door in the next example. We create that intent, and we have our action defined. So how we invoke this action? We will ask Alexa, probably check door. Who's at the door? Who is there? Spy on door. And we could put list of many other examples that come to our mind. When we now build this model, first we need to save it. Then we get the message that interaction model was saved successfully. We say build. What happens now is that natural language processing model is built in the background, and based on those utterances you listed over here, it's trying to figure out, okay, all possible combinations, which means like if you invoke your skill and say something that's not here, Alexa will still try to figure out, okay, this is the action that user is trying to do. Later on, if you go with skill all the way to the store and publish it there, you can also check, okay, how users are using my skill, like which commands are they using. So you can figure out, are all those commands recognized and executed. Build was successful, as you can see over here. So let's move to the code. That's the next tab over here, and here we can see that is our Lambda, and we have 3 files over here. This Alexa skill lifecycle is basically here. You can follow it on these tabs. We were in build, then we will write some code, we will test it, then we can distribute it to the store, and so on. Let's stay at the code tab. So over here we have index.js, we have our package JSON, which is just one description JSON. We have util.js, which is used in case that S3 assigned URL is needed. So basically, we only want to take a look at this index.js file. Over here, if we follow the code a bit, looks like a lot of code, but it's super simple. And code is split into those request handlers. So we have launch request handler, which will be executed when skill is started. So over here, first we check can we handle this input, and is it a launch request? And if it is, we define one variable speak out, where we will say some text. We will send it back to our device to say. So let's change this one, and let's say it will say hello Nordic Serverless. So when our skill is started, it will reply back with hello Nordic Serverless. We see here, if we go a bit down, we have help intent, we have cancel and stop, and we have those standard ones. We have also that one custom, which was hello world intent, right? We added second ago, we added another one, which is called the door intent. So we just copy pasted the existing one over here, and we changed it names into door intent handler. In can handle, we need to check, is it intent request and is it door intent? We are trying to run here, and if it's the door intent, we will say I wanna check who is at the door. One more thing we need to do, since we added this door intent handler, we need to scroll down to the list of our request handlers, and into list of our handlers, and we need to add it to the list. But please make sure that intent reflector handler is the last one. If you take a look at the comment, that's what's written over here. So we added our door intent handler to the list. We save our skill and we deploy it. We get the message deployment initiated. And in a few seconds, it is successful. Okay, so we defined our build. We have two actions we can do, hello world, and we can do this door intent, custom one, which we defined. And we can invoke it, for example, with check the door. So for this door intent handler, in our code, we wrote one function that is handling it, right? And it will speak out, I want to check who is at the door. So we go to test. And over here, you can test your skills. Same way you are testing on the real device. And it's really nice feature if you don't have device at home, but I strongly suggest that you get yourself one, maybe not 14 as Gunnar have, but one would be enough for sure. So Alexa skill on device is opened with wake words. You can say Alexa, Amazon, Echo, computer, those 4 wake words. And you say, Alexa, open the skill open skill name. On simulator, difference is that you don't need the wake word, so you can say immediately, open Nordic door. That's how our skill is called.
The requested skill did not provide a valid response.
So I have a not Nordic door, Nordic skill. Open Nordic skill. Sorry about that.
Hello, Nordic Serverless.
So we started our skill, and we changed the welcome message. That is first message that is displayed, right? Hello, Nordic Serverless. So we say check door.
I want to check who is at the door.
And we triggered our custom action that we wrote in a code over here. So this is the intent that was triggered. In this code, you can do many different things. Depends what your skill wants, what you want to do with your skill, right? But now I would also like to show you how to build everything from scratch. And I will just copy this code so we can reuse it later, and I'll just paste it here in my text editor. Okay. And we will go back in our console to create new skill. Let's call it door spy. We will select, we can select the language over here. We say we want to build a custom skill, and this time we will provision our own. So Alexa console will not take care of the things like last time. So we say create skill, and we want to start from scratch. So we are back into developer console, and now we see that only invocation name is set. Why is invocation name set? Because invocation name initially is set to the value of our skill name, door spy. So when I click invocation, it should be door spy over there, right? So we can invoke our skill by saying open door spy. At the moment, we have only built-in intents, and we want to add one intent that will be called door intent, like last time. And same way, we will say check door, spy door, who is at the door, who is there, and so on. We can add different utterances that will invoke this action. So now we save the model, and we can also build our model. Since we are not planning to add at the moment any other intents, we only want to have in our skill, to keep it simple, this one action. We will be checking who is at the door, and by checking that, we will invoke the lambda function, and lambda function will execute some code. We'll take the picture that Gunnar prepared, we'll put it in AWS recognition, and will give us result back. Who is at that picture? So now model is training, and it's successful message. If I go click here back on the build, you can see we had invocation name. In the meantime, we defined intent, and we now build the model. So what we are missing endpoint. This is now what we need to do. We need to create one lambda that will be invoked by our skill. Just before I go to the lambda, I just wanted to show quickly Amazon recognition is really powerful tool, and offers a lot of features like labeling your pictures, figuring out like what is in those pictures, detecting text, face detection analysis, face search and verification, and so on. So what we're going to use is celebrity recognition. We will take the picture and give it to the recognition to tell us, is there a celebrity in that picture? In order to do so, we will go first to the AWS Management Console, and over here we will open the Lambda. We will create function, and let's call it Nordic door. We will author it from the scratch, and we will use Node.js. We click create function, and we give it a few seconds. So our Lambda is now ready. We can see the Alexa skill development kit. I will open up the terminal, and as you can see over here, I'm in some folder door spy. There's nothing at the moment in this folder, and I want to use to install SDK ASK SDK core. Sorry, there's a typo. We give it a second. And I also want to install the model. Okay, fine. So this got installed. Door spy, right? If I check our node modules, I see I got the core model and runtime over here. So only thing, I also got the package JSON over here. So only thing I'm missing is my index file, and I took the copy pasted code from the last example. So I will save that one. In this folder as index.js, right? So that's the code we used few seconds ago. I want to check who is at the door. Let's go to the folder. Take these three files, create compress them. We made the archive. Go into our Lambda function. We want to upload the zip file. We click the upload button, open this archive. Okay, and we click save. And we got our modules uploaded together with index.js and basic code for the Lambda. What we need to do now, we need to add a trigger, and that trigger to our Lambda will be Alexa skills kit. And when we invoke our Lambda, we can also make this skill ID verification. But at the moment, that is not needed for this example, so I will disable it. Of course, here, if you are building skill for a store, this is something you should do. Okay, so going back to our Lambda, I will use few code snippets to make this work faster. So what I'm going to add now is I will define the AWS recognition. So I will be able to invoke it later in the code. What we had over here in previous example, we had two handlers, hello world and door intent handler. So I will remove hello world from the list here, and I also need to remove it from the list at the bottom. Always remember that, and of course there is there are warnings that will show you what's going on. Okay, so we define recognition, and now in our door intent handler, we would like to invoke that recognition. So over here, it's called door. It's called intent spy door. So I'll change this. Let's copy this door and recognize door. I'm replacing the existing one with the code and adding one more function. So our door intent handler is doing the same thing. It is checking like, is it intent request and is it a door intent? So this is the action we want to do, and then defines one variable that is recognize, that will call the function recognize door. And what this function does, it first defines some parameters. It defines the parameters name of S3 bucket, and at the moment, if we go to S3, our bucket is called like this, and the picture that Gunnar prepared is called like this. We will copy that over here. So we define the bucket name and name of the file, and then we are calling recognition, and we are calling recognize celebrities with these parameters, right? If there is error, we will log in the console. Otherwise, we will try to resolve this response, and this response comes as a JSON that has array of celebrity faces. So we will take from that response first celebrity face we find, and from that first face we will take the name. We define variable speak out as I see that name. So basically from our JSON we read the name, and Alexa should speak out what we are returning back. I see some name, right? So let's save this. And there is one more thing I need to do. I need to set my permissions. So in permissions, in the role name, I need to attach a policy. And if you search for recognition, I will now add it full access, let's say. So I attach this policy, and now everything should be ready from this side. We will take Amazon resource name ARN. We will copy it here, and we will go back to our developer console and click on the endpoint. In endpoint, we select how we want to invoke this service. So we can invoke it via the Lambda or HTTPS. We choose Lambda, and we paste our service name over here. We save endpoints, saved successfully, and we will move to test. So we will enable test. We will open our skill, open door spy.
Hello, Nordic Serverless.
So Lambda code got executed, and from that Lambda code, we got the greeting, hello, Nordic Serverless. So launch request works now. And now we want to invoke door intent handler. And over here, we will say check door. That's how we defined it, will check the door. So
I see George W. Bush.
So what happened now? Our code got invoked in the Lambda. We sent this picture to recognition, to recognize celebrities. It's this picture over here. I can click open. That's the picture. Picture got recognized. We took the name of that celebrity from the picture and sent it back to our Alexa to say it back. And that's the response we got. So those were two flows, like quick flow, how you can build Alexa skill, and a bit longer, which is building skill from scratch. Gunnar, would you like to add anything?
No, that was great. And it actually recognized George W. Bush. So I'm really satisfied.
Yeah.
So fun to see. And when you normally develop these types of skills, do you start off with some boilerplate code that you have already, or do you usually start off with the sample ones?
I probably use the sample ones because, like, you need those standard intents defined, and that's most of, like, 80% of that code is the standard one, and then you have that one hello world intent. So that's how you do it.
Yeah. You've shown me that you built Alexa skills where you've connected to Lego devices.
Yeah.
Can you tell a bit about that?
I had a few fun projects earlier, and for the Christmas project with my son, what we actually built is the Lego T-Rex. He built Lego T-Rex. He's 12 years old, and from Lego Mindstorm. So we connected Alexa to it, and it was able to recognize different voice commands and turn on motors based on that. And hopefully you can see in video, like, this command, like, move forward when he's saying, and now it's turned on and moving forward. It has infrared sensor on the top, so when he puts the hand in front, like say to Alexa, turn on guard mode, and now infrared sensor is on, he will put the hand in front and T-Rex will try to bite him. It's one fun project you can do, for example, or on one hackathon that was, like, I think 2 years ago, we connected Alexa to guitar, also with Lego Mindstorm, and one motor was hitting strings, the other one was pressing the chords, so it was actually playing the guitar, and we managed to get the lyrics synchronized with what it was playing. So yeah, a lot of interesting IoT things that can be built with Alexa, and I think also with this example we showed today. You could, for example, put it in the post box, and then it could check did the mail arrive, and so on. Can be built really a lot of things.
Yeah, and connecting these two things together, like the Lambda function that was used in my example first to get the camera to take a picture, that could be invoked using Alexa as well. So
Yeah.
So telling Alexa to take a picture, which will then take a picture and save it in S3, which is then loaded. So building upon this can be a base, something to develop more on, of course. So yeah, really fun. Great to have you here today, Goran. Great to see how you build skills from scratch and actually do something that is useful this quick as well.
Thank you. It was really fun to do. Yeah, great project.
Yeah, so I'd love to have you back sometime in the future, and then let's come up with something new to build then. Make it even more fun then. So great. Thank you very much, Goran. If people want to reach you, how do they do that?
They can find me easily on the LinkedIn and Twitter. That's where I'm most active. So yeah, if you build something interesting, feel free to poke me, show me. I like the techie projects and would like to see what people manage to do.
Great. All right. So thanks once again, Goran, and see you soon again.
See ya.
All right. And with that, it's the end of this time. But Nordic Serverless will, of course, be back shortly with yet another meetup. So keep an eye out. And that's it from me. I'm Gunnar Grosch, and thank you very much for watching.